Today we are going to be looking at patterns and characteristics of physical processes. I've abbreviated here and it's kind of extended over. I'm running out of board. But we're looking at the physical processes from last unit, but we're looking at how the different patterns and characteristics make that up. Your essential question for today is, why are there climates in the world? The next question is I already know the answer. Does location affect climates? It does, but why? Why does location affect climate? That's what we're going to be looking at today. Now, the first subset that we've got, the effects on temperature and climate. There's many different things that affect temperature and climate. The most important effect on climate and temperature is latitude. What I mean by that, the Tropic of Cancer and the Tropic of Capricorn, and then the equator, this area gets more direct sunlight than anywhere else in the world. So this latitude zone is going to be warmer than anywhere else in the world because it gets the most direct sunlight. The further up and down you go latitude-wise, the different climates and temperatures you are going to have. That is the most important effect on climate. And again, we've got three different types of latitude zones, and we'll look at that later. Low, mid, and then high. Okay, we'll cover those three in just a little bit, but latitude is the most important one. Latitude, 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 I can't express that enough. The next thing that can affect temperature and climate is elevation. For example, if I'm right on the equator and I know it should be warm, but I'm standing on top of a mountain, it's going to be cold. Okay? Temperature decreases on average about 3.5 degrees Fahrenheit every 1,000 feet you climb. That's what that says there. So this little man at the top of the mountain is really cold, but then this guy at the bottom is warm. All right, it's because of that elevation. Next thing that can affect temperature and climate are the wind systems. The definition for wind is air moving across the earth. That air that moves is wind. Okay, there's many different reasons that cause wind. The heating and cooling of the Earth's surface creates this movement of air known as wind. Most of the time you have prevailing wind systems, and these are the predictable patterns that are traveling in straight lines. But then every once in a while, like a Coriolis effect, because of the rotation of the Earth, that wind system changes and moves diagonally. Depending on where you are in the world, you may have different wind patterns that affect your temperature and your climate. Also, we have ocean currents. Ocean currents can affect temperature and climate. First off, there's cold ocean currents and there's warm ocean currents. An example that I've provided you here is the North Atlantic Ocean Current. This is the one that's near Europe. This ocean current is warmer, and temperatures around this area are warmer because they're next to this ocean current. Latitude-wise, they should be close to the high or the mid-latitude zone, so they should be colder. But because of the ocean current, it's not so. Also, we've got El Nino. I'm getting ahead of myself. Still looking at ocean currents. An important factor to know is that water heats and cools slower than land. So temperatures around these areas are going to be more consistent next to the water than if you're a long ways from that water, because land, Earth, the lithosphere, heats and cools quicker than water does. Water is slower, so temperatures aren't going to vary as much. Now, moving on to El Nino. Your position on a continent could also affect your temperature or your climate. For example, if you're next to this ocean current, it could be warmer or colder. If you're in the position of the continent where the wind pattern has changed, it could be warmer or colder. For our purposes in Texas, there's a good example of the El Nino. If you're positioned right on our continent, like the southern area around Texas and Mexico and that area, if it's an El Nino year, you get more rain if you're in Texas. On the flip side of that, if you're positioned on the Southeast Asian continent, if you're positioned on the southeastern portion of Asia, you get less rain because of El Nino. So again, position of the continent can be a determiner of temperature. That's very important that you get. Mountain barriers can also be effects of climate and temperature. Probably seen the rain shadow effect before. As wind blows across water, it's wet, and then as it gets over the mountain, it can be dry, and you can literally go from forest on one side of the mountain to a desert on the other. The example that I use is Cloudcroft, New Mexico. You come up from the forests, and then you go down, and you're on the leeward side, and it's dry. It's like a desert. Next thing that I'm switching gears here. We're looking at forces of change and the processes of forces of change. I'm not going to spend a lot of time on this. These are also known as other things, and we'll talk about. The first type of change is a subduction. This is when the heavier oceanic plate, more dense, drops beneath the continental plate, and you have that sinking motion. Okay, a lot of times a volcano will form because of this, but you have that heavy plate dropping down. This is also known as a convergent. You also have what's known as faulting. When these plates side by side move, sometimes they could buckle, and when they do, you have faulting that occurs. And what actually happens is this portion of the land kind of sinks down because that land is buckled and moved. So you see the sandy portion, the rocky portion that looks like bricks, it just sinks because of this faulting, also known as transformational fault. Then you have spreading. This occurs more under the ocean surface. This is when two plates move away from each other. They create a gap. A lot of times it's in the ocean. We'll get to that in just a little bit. Now, specific landforms that are formed because of these forces of change. You have faults in the Earth's surface that forms from faulting. You have trenches underneath the ocean because of the spreading and the split of the different plates. You have that hole, okay, or canyon. Volcanoes can form from the subduction zones. As they subduct, that magma can leak up and create a volcano. Some weather processes that can occur because of these. Tsunamis occur from subductions underneath the Earth's surface as that land buckles above on the water's edge. You have a rippling and a huge wave that's created because of this subduction underneath the Earth's surface. Again, earthquakes can occur, and that results because of faulting. Some also known as transformation faults are also known as faulting. Convergent plates and movement is also known as subduction. Divergent plates is also known as spreading. Now, climates and biomes. We're looking at the 3 different latitude zones. Again, latitude, latitude, latitude is the most important aspect of influence on climate, your latitude. There's 3 different types. The first is the low latitude zone, which I kind of got at earlier in the notes. Low latitude zone is in between the Tropic of Cancer, which is this top one, and the Tropic of Capricorn, which is this bottom one. Okay? This is 23.5 degrees north, 23.5 degrees south. This is 0 because this is the equator. This is the area that gets the most direct sunlight. You'll notice from the previous section of notes, if you don't remember this, you might go back and check it out again. But the Earth's direct rays hit in this area in one portion of the year, and then it shifts down to the equator, and then it shifts down here. So if the direct rays are here, this area is in winter. If the direct rays are here, this area is in summer. Okay? These are the low latitude zones. These are the areas that go from warm to hot. That's generally your temperature change. These are also known as the tropics. You'll notice that most of the tropical rainforests, pretty much all of them, are located in the tropics. Amazon rainforest, rainforests of Vietnam in those areas, they're in the low latitude zones because of this warm, muggy environment. Doesn't necessarily mean dry. It can. But it's talking about this heat from the direct sunlight. Next type of latitude zone are the mid-latitude zones. Mid-latitude zones. If this was my Tropic of Cancer and this was my Tropic of Capricorn, I know this is my low latitude zones. The latitude zones just north and just south of that are the mid-latitude zones. These are the most varied. These go from the Tropic of Cancer in the north to the Arctic Circle. These go from the Tropic of Capricorn in the south to the Antarctic Circle down here. Okay? You have warm summers in this zone and you have really cold winters in this zone. Most varied temperature zone and climate zone. You're going to see a huge variance of climates here. The last climate zone that we are looking at is the high latitude zones. Okay? If I had an Earth's surface and I had my mid here, these would be my high latitude zones. Even this one down here, my high latitude zones. Now the easiest way to remember that is these are the areas next to the poles. Okay? If I had my low, I had my mid, now I have my highs. This is where Santa Claus lives. Okay? In the North Pole, he lives in the high latitude zone in the North Pole. Cold, 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 cold in this area. Sometimes these areas get 24 hours of sunlight, and then another time of the year they can get 24 hours of darkness. Okay? Because of the tilt of the Earth, because of the rotation of the Earth, and because of the way it's facing the sun and where the sun's direct rays hit. If that tilt is here, this North Pole will get 24 hours of sunlight if the sun is here. Flip side of that, if the sun is over here, this top side and parts of the high latitude zone, this top side, may receive 24 hours of darkness.